Morning, this is your Stats Sensei, Mr. Sensei, and this is a pre-quiz on classical and conditional probability. We're going to break this up into a couple of videos. So, real estate advertisement provide the following information about houses in the Stone Oak area with regards to two-car garages and five bedrooms. Use the Venn diagram below to answer the following questions. So we look at this, we go, okay, five bedrooms, that's represented by this circle. And then we have two-car garages represented by this circle. You know what? I'm going to go ahead and circle this. So five bedrooms is circled in pink. That's the probability of five bedrooms. And it says, what's the probability a house has a two-car garage? And I'm going to go ahead and circle this in green. So that's two-car garages. And if it's got both colors, then they have both. So what's the probability a house has a two-car garage? Well, two-car garage was circled in green. So the probability is going to be, the probability of the two-car, so 0.72 plus the probability of both, because it wasn't two-car only, has a two-car garage is this entire green circle. So in this case, that probability is 0.81. Okay, what's the probability a house does not have five bedrooms? Well, what's the probability a house has five bedrooms? Anytime the key word here is not. So anytime you have not, you're going to deal with a 1 minus. So what's 1 minus the probability it has five bedrooms? Well, the probability of having five bedrooms, we said, was circled in pink. So let's subtract that from 1, and that'll give us our answer. So that's going to be 0.07 plus 0.09. So that gives me 1 minus 0.16, which equals 0.84. And that's my answer to that one. What's the probability a house does not have either? Gosh, that's not even drawn on this. So we're going to have to do a little bit of work. Either to have not either, that means it has to be outside. So it has to be outside that circle. And once again, the key phrase is does not. So we know we're going to do 1 minus. And so we have to do 1 minus the probability of five bedrooms or two-car garage. So as soon as we do that, we're looking at the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. And you're like, well, there's no A and B's. And you're right. So how about this? And it looks like I'm a little bit frozen. That's not good. So the probability of bedroom union garage equals the probability of bedroom plus the probability of garage minus the probability of bedroom and garage. Well, in this case, what's the probability of five bedrooms? The probability of five bedrooms is 0.16 plus the probability of a two-car garage is this entire green circle, because essentially this is the probability of five bedrooms. This is the probability of the garage. And then we need the probability of the intersection. And that intersection happens to be 0.09. Okay? So when we add all that up, we go 0.16 plus 0.81 minus 0.09. 0.16 plus 0.81 minus 0.09. And that gives us 0.88. So the probability of having either having five bedrooms or a two-car garage or both equals 0.88. So in this case, when we go 1 minus 0.88, it equals 0.12. 1 minus 0.88 equals 0.12. Okay, continuing on. Now, that's not the only way to have done that. The other way to have done it is go, oh, so that means this area out here, not having either, is 0.12. That's the area outside the square. And if I add all this up, and I did this correctly, it should add to 1. So let's check it out. 0.07 plus 0.09 plus 0.72 plus 0.12. And sure enough, it adds up to 1 or 100%. So someone's probably going, well, could you have just done this? And the answer is, yeah, you could have gone 1 minus parenthesis 0.07 plus 0.09 plus 0.72. And let's look at that real quickly. So if we had done it that way, which is probably easier, 1 minus parenthesis 0.07 plus 0.09 plus 0.72, we get exactly the same answer. All right? So the probability of neither is the probability of 1 minus the or. So anyway, that's the way you can approach that problem, two different ways. In a certain school, 19% of the students are enrolled in psychology. Okay. 33% are enrolled in statistics. And 58% are not enrolled in either. Complete the Venn diagram. Be certain to include the percent of people who are enrolled in both courses. Okay. So first off, I'm going to say, you know what? This pink one right here is going to be psychology. And we know psychology, what do we say? Psychology. Now we have to be careful. We can't put the 19% here because some of that 19% is going to be in both. And we know that this part is going to be 33% for statistics, but some of it's going to be in the overlap. So this is going to be stats. So we have psych and we have stats. And we know 58% are not enrolled in either. That means this right out here is 0.58. This is the neither group. Okay, so let's think about this real quick. We have the probability of A union B equals the probability of A plus B minus the intersection. Well, in this case, we know what A union B is going to be. It's going to be 1 minus 0.58 equals the probability of A union B. But it's really not A union B. Let's rewrite this in the way that this problem is. It's the probability of psychology union stats equals the probability of psychology plus the probability of stats minus the probability of psych and stats. Well, that means this right here is the probability of psychs unions. Okay, so 1 minus 0.58 gives me this. So this right here is 0.42. Well, that means the probability of psychology, well, we know that's 0.33. Oops, 0.33. The probability of statistics, probability of psychology, I'm sorry, is 0.19. Probability of stats is 0.33 minus, we don't know what the intersection is, probability of psych and stats. So we know that that's the stats. We know this is psychology. And we said this was the neither. So let's go ahead and do a little bit of math. When I add 0.19 plus 0.33, I end up getting 0.52. So 0.42 equals 0.52 minus the probability of psych and stats. I need to subtract from both sides. This goes away, and I end up with negative 0.10 equals the negative probability of psych and stats. Well, I can just change the signs, and this gives me both. Remember, this is my symbol for both. So both is right here. So we know that this is 0.10. That means the probability of psychology is 0.19 minus 0.10 equals 0.09. That's the probability of psychology only because psychology is this entire circle. Well, the probability of stats is going to be 0.33 minus the 0.10, which is equals 0.23. Because stats, once we began, they told us it was 33%. It's this plus this. Okay? All right. Next problem. If the probability of A is 0.47, probability of intersection is 0.13, and A union B equals this, well, then what's the probability of B? Well, A union B, that tells me I need to write the probability of A union B equals the probability of A plus the probability of B minus the intersection. All right. Well, I know what A union B is. I know this is 0.81. I know the probability of A is 0.47. I don't know the probability of B, so I'm just going to write B. But I know the probability of the intersection is 0.13. And let's go ahead and do a little bit of highlighting. We know that this is 0.47. That's where that came from. We know A and B, or A union B. And that's this. And we know the probability of A and B, which is my intersection. So the only thing we don't know is B. But if I add these two together, I end up having 0.81 equals this plus this is 0.60. So B is B, but this 0.47 minus 0.13 equals 0.34. So this is B plus 0.34 or the other way around. And if I subtract B 0.34 from both sides, I have 0.81 minus 0.34, and I get 0.47. So 0.47 equals B. Guys, I can't tell you how important it is to write the formula and start plugging in the information that you have. Okay? All right, continuing on. The situation below and the spinner are for questions 6 through 10. At a local carnival, people spin a wheel to receive prizes. Each section of the wheel is equal in size to the others. The spinner is equally likely to end on any one of the sections. What's the probability a carnival participant doesn't win anything? First off, how many sections are there? Well, if I count, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 sections. All right. And what's the probability they does not win anything? Well, that would be 1, 1, 2, 3, 4, 5, 6. Well, if I counted correctly, which is no promises, but if I counted correctly, that looks like to me that there's 6 times they win nothing. So in this case, 6 out of 10, which is 3/5, which equals 0.60. Okay. I have to see that first fraction. This is a must-have, and then I'd like to see you convert it to a decimal. What's the probability carnival participant receives less than $10? Well, how many times does that happen? When I look at the wheel, it's like less, 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 and less. All but one of them are less. So that would be 9 out of 10 equals 0.90. Once again, I need to see that fraction. You could have also said, well, there's only one time that it happens, so 1 minus 1/10 equals 9/10. But we need to get it converted. We need to see the fraction, and I need to see it converted to a decimal. And if you're wondering what we did to do that, we had, well, that's good enough. What's the probability that 4 consecutive customers win at least $1? At least means they could win more than $1. Okay, so we have 4 consecutive customers. So 1, 2, 3, 4. So how many times do you win at least $1? Well, 1, 2, 3, plus the $10, because that's at least $1. So 4 out of 10 times 4 out of 10 times 4 out of 10 times 4 out of 10. Or you could have just done 4/10 to the 4th power. And that's what I'm going to do right here. Parenthesis 4 divided by 1/0. Use the little caret, and we needed 4 of them. And we get 0.0256. Once again, I have to see the fraction. Either you're going to show me in blanks or you're going to show me like that, but I have to see that. Okay. What is the probability that 5 customers in a row win nothing? Well, here we're dealing with 5, so I need 5 blanks. 1, 2, 3, 4, 5. Well, this is going back to like our first question. How many win nothing? 1, 2, 3, 4, 5, 6. So that's 6. So this is 6/10 times 6/10 times 6/10 times 6/10. By now, I'm getting really tired of this, and I go, couldn't I have just written 6/10 to the 5th power? And the answer is yes. Want to see that. And then we're going to go clear, parenthesis 6 divided by 1/0 raised to the 5th power, and we get 0.077. Now I'm going to go ahead and write all the decimal places, but you need to have at least 4, but I'm going to write all of them. 10. What's the probability the first dollar winner occurs on the 5th spin? Okay, we're dealing with a first. Okay, so this one wins $1, but this is not a win, not a win, not a win, not a win. Not winning $1, not winning $1, not winning $1, not winning $1, winning $1. Well, what's the probability of winning $1? 1, 2, 3. 3 out of 10. That means these are 1 minus 3 out of 10. And if I did that, that would give me 7/10. Not winning $1. Because look, 1, 2, 3, 4, 5, 6, 7 is not winning $1. Now someone goes, is there a shorter way of writing this? And yes, there is. I could have written as 7/10. How many times does that occur? 1, 2, 3, 4. All right. So let's do that work. parenthesis 7 divided by 1/0 raised to the fourth power, parenthesis 3 divided by 1/0, parenthesis 7 divided by 1/0 raised to the fourth power, and times 3 divided by 1/0. And we get 0.07203. The XYZ office supply company sells calculators in bulk at a wholesale price as well as individual at retails. Next year's sales depend on the market conditions, but executives use probability to find estimates of the sales for the coming year. The following tables are, okay, so we expect to sell 10% chance we sell 2,000, 30% chance we sell 5,000, 40% chance we sell 10,000, 20% chance we sell 20,000. So they want to know the expected numbers. Well, what I need to do is I need to put this into L1 and L2. And when I do that, it's going to take me just a moment. I'm going to put in 2,000, 5,000, 10,000, and 20,000. And over here, 0.1, 0.3, 0.4, 0.2. Stat, calc, one variable statistics, blue 1, then blue 2 because I need my freak on. And we get 9,700 because X bar, the expected number of calculators, is the average or mean, which is the X bar. So in this case, 9,700 calculators. Okay, it says complete the table and find the expected value and the standard deviation. Well, remember, all valid probability distributions need to sum to 1. This one up here sums to 1. 1 plus 3, that's 4, plus 4 is 8, plus 2 is 1 whole. When I go to this, I'm missing a spot. So let's fill that in. So 0.35 plus 0.25 plus 0.15 plus 0.05. So this is 0.8. So we're going to go 1 minus parenthesis 0.35 plus 0.25 plus 0.15 plus 0.05. This gives me 1 minus 0.8, which equals 0.20. And remember, this plus this plus this plus this has to equal 1 whole. So it asks for the expected value and standard deviation. Well, I just need to input this information into column L1 and L2. So I'm going to go press the stat button, edit. I'm going to go to the top and press clear, top and press clear. And I have 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. And then 0.35, 0.25, 0.15, 0.05, 0.2. Okay, so stat, calc, one variable statistics. Blue 1, we need our freak on, which is blue 2, because our frequency is in L2, that's our probability. And the expected value is 1.5, because that's the same as saying my X bar or my average. Or it could have said my mean. All those mean the same thing. Then it asks for the standard deviation. Well, my standard deviation is 1.5. In this case, it happens to be the same thing. But this right here, the standard deviation, is this symbol. So please don't forget that. Okay, continuing on. Many women have annual mammograms after age 40 to screen for breast cancer. Mammograms are not perfect and sometimes produce false positives and may also produce false negatives. In Stone Oak, 1% of the women over 40 currently have breast cancer. 97% of the time, the mammogram will detect the cancer in women, etc. answer the following questions. Well, they have the table already filled out, so we don't have to create it. So what's the probability that a randomly selected woman has a positive mammogram? Well, we're looking for the probability of positive over the total because we're looking at, so positive over the total. I'm going to call this plus over total equals 0.0691 over 1, which just gives me 0.0691. What's the probability a randomly selected woman tests positive and has cancer and does have cancer? So positive and has cancer. So positive and cancer over the total. Well, positive is right there. And cancer, and please remember, and has the intersection sign mean in it, and that means intersect. And that's where the two streets cross. So positive and cancer, well, positive and cancer is right there. So 0.0097 over 1 equals 0.0097. Given, as soon as I see given, I know there's a given down here, and I know that I have to have intersection over given. Well, what was I given? I was given the test is positive. So given a positive, what's the probability she does have cancer? Okay, so cancer given positive. That's what I have. So first off, given the test is positive. Okay, that's what I was given. So this is going to be 0.0691 because that's what I was given. What's the probability she has cancer? Okay, so now I need to intersect. Where does it intersect? It intersects at 0.0097. That's where the intersection is because this is cancer and positive. So there's my fraction. And 0.0097 divided by 0.0691 equals 0.1403. And we can just truncate at 4 places. Okay, suppose 4% of the population have a certain disease. A laboratory, and here we got to create a table. A laboratory blood test gives a positive reading for 95% of the people who have the disease and 5% of the people who do not have the disease. So when we're talking about this, it's like, well, what are our variables? Well, our two variables in this case are disease, and you can either have it or not have it, and test result. And the test results will either be positive or negative. And then we have or not have. Those are my choices. So disease, have or not have, test results positive or negative. Well, when I have a problem like this, I need to identify the one number that's associated with only one variable. Suppose 4% of the population have a certain disease. Well, 4% have a disease. Does this anywhere mention, and when I look at this, does it anywhere mention that they test positive or negative? It has nothing to do with test results. It has to do with disease. So that's the one number that only associated with one variable. So I know that this is going to be 4%. Well, 4% as a decimal is 0.04 because you always divide it by 100. Well, I know that this is going to be 1 minus 0.04, so this is 0.96. So before I go any farther, this is going to be disease and no disease. Okay, and so this right here is my disease variable. So this is going to be my test results variable, which means I can either be positive or negative. Now, I know some of you aren't going to write that out. You're going to write plus and minus, and that's fine. There's nothing wrong with that. Okay. So once let's look at these other variables, numbers first. A laboratory blood test gives a positive reading for 95% of the people who have the disease. So this says positive, but have the disease. So that's two different variables. So that has two, that's associated with two variables because positive, which is test result, have disease, that's disease status. 5% of the people who do not have the disease, and it's a positive reading for 5% who do not have the disease. So once again, two variables. And we only want the one with one, which is this one. Okay, once we have those values, we write them small. So this is going to be 0.04, 0.04. This is 0.96. This is 0.96. Okay, so where does this 95% go? A laboratory blood test gives a positive reading, so we know we're looking at the positive row for 95% who have the disease. Oh, so this means this is 0.95, and because it's associated with two variables, I have to write it small. And this is just going to be 1 minus 0.95. So let's multiply those out real quickly. So 0.04 times 0.95 is 0.038. And in this case, we have 0.04 times, or 0.04 parenthesis 1 minus 0.95, and we have 0.002. Okay? So if I check these two values up, this plus this equals that, so that looks pretty good. Here, positive reading for 5% who do not have the disease. By the way, I guess I can highlight this like this, boom, 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 and who do not have the disease. So they do not have the disease. What is that? And I'll just make this like this. So 5% for do not have the disease, but it's positive. So that means this right here is also 0.05. And this is going to be 1 minus 0.05. So let's multiply that out. 0.96 times 0.05 is 0.048. And 0.96 parentheses 1 minus 0.05 gives me 0.912. This plus this equals that, so that looks good. So now we need to add across. So we have 0.038 plus 0.048 is 0.086. And we adding across, 0.002 plus 0.912 gives me 0.914. If I add up these two, they better add up to one whole. Let's hope they do. 0.914 plus 0.086 adds up to one whole. So it looks like to me that we probably did this right because this plus this equals this, this plus this equals this, this plus this equals this. We add up rows and columns, they all add up. That looks pretty good to me. All right. Appreciate you watching. I hope this helped. Good luck. Thank you.